All right, in this question, we're looking to solve for A. So we have either at BCC or FCC. Now, if you remember BCC, it has a little bit less packing than FCC. So it's got one in the middle and then the 1/8 of each one on the outside. Now we're solving. Now, if you do the space filling model, right, we can solve for A, and we showed the math. If you go, from one corner to the other and do the math, you get for BCC, you get A equals 4R over the square root of 3. Now FCC, which is a little bit more packed, we got the 8 corners again, but then we have half of one on each face. A little bit harder to draw. And so we can actually, by going across on one side, find 2R. So we solve that. And again, A is, what is this distance here, A? And you'll see later on that we are going to find the density by using this volume A cubed. How many atoms are in a unit cell, which is A by A by A. And so we'll use this later on. So FCC is A, and we saw it was the square root of 8R, which also can be written as 2 square root of 2R. And now one thing is that square root is not in the R is not in that square root. So don't include it in there. Okay, so what we're doing is we're given the lattice constant, and we got to calculate the radius. A lot of the other ones, you'll be given the radius and you'll calculate the lattice constant. When you do that, it's a little more straightforward because you're just given you're given R and you solve for A. So here we have to rearrange a little bit. And because it's BCC, so we have A equals 4R over square root of 3, and we're given A, so we're going to say square root of 3A equals 4R, and then we'll divide by 4. So R equals the square root of 3 times A over 4. So that's what we're going to do. Now, we're going to solve in picometers for the radius, which is a typical radius distance. So we don't need to convert units. And so we will just plug it in. So if we solve for radius, we get square root of 3 times 321 picometers divided by 4. So square root of 3. Now, you might even hit equals there, then times 321 and then divided by 4, and I get 138.997, which I will call 139 picometers for the radius of this metal. Okay, it does like to have that point, which I don't necessarily agree with, but it is more math-based. So there you go, 139 picometers for the radius. Now, so be careful, BCC, FCC, those are the two that will be in this objective. And then, so using the right formula based on that packing density.